All right, good morning and welcome to Master Talker online class. In this video, we'll be talking about balancing of redox reaction, right? Don't forget that in our previous video, we have talked about redox reaction. Redox reaction is a reaction that contains oxidation and reduction reaction, right? So in our former video, you can go and watch to know what is oxidation, what is reduction, and so on and so forth. But please, if today is your first day of watching our video, please click on that subscribe button, okay? So that anytime we drop a video, YouTube will notify you. Now, right, redox equation equally obeys the laws of conservation of matter. Okay, so when balancing redox reaction, both atoms, ions, charges must be balanced. All right, so they must all be balanced. So the following steps are taken when balancing redox reaction. The first one is we break the equation into a half into two equal parts called a half cell. We break it into a half cell. Let me use an example to illustrate that. I have Cu2 plus, okay, plus Al, okay, to give Cu plus Al3 plus. Right? So the first thing we do is to break it down into two half cells. So therefore that is Cu2 plus to give us Cu, and then Al to give us Al3 plus. All right. So the next thing we do, number 2 law, you can write it down, is to check their charges and then add electron to the side with the greater charge. So if you look at this, see that the charge of this is what? Plus 2, and the charge of this is 0. The charge of this one is 0, and the charge of this one is plus 3. Okay, so this is bigger than this by 2. So I'll add 2 electrons to this side with the bigger charge. So which is what? Cu2 plus 2 electron will now give us what? Cu. Okay, so we still add electron. This one is bigger than this one by 3. So you say this minus this. Okay, we are not adding because of the 3, but because when we subtracted, we saw that this is bigger than this by 3. So I will have that. So I will now have that what? This is Al to give Al3 plus 3 electron. All right. Okay. So having this now, the next thing we do is to check the ratio of the electron. This one is 3 this one is 2 electron to give is to what? 3 electron. Very simple. So the next thing you now do is what? To cross multiply. Use the electron here, the number of electron here, to multiply everybody here. Use number of electron here to multiply everybody here. So this is 2 times, okay, let me start from here. 3 times this will give you what? 3 Cu2 plus 3 times this will give you what? 6 electron to give 3 times this to give you what? 3 Cu. Okay, then 2 times this will give you what? 2 Al to give 2 Al3 plus what? 6 electron. So you now notice that the 2 electrons are now equal. You cancel them out, they will be out. So my answer will now be bring the reactant to the reactant and the product to the product. So I have 3Cu2 plus 2Al, okay, to give what? To give 3Cu plus 2Al3 plus. Okay, so this is a well balanced redox equation. Okay, so the next one, let's solve another question. Question number 2. This is very simple, very simple. So I forgot to tell you that if electron is added on the right hand side, like in the other one we added the electron on the right hand side, so what does it mean? It means that it's an oxidation reaction. Please, electron was added on the left hand side of the other one, it means reduction reaction. Please don't forget that. So please, I forgot to tell you that. So let's do another example. This one said that what? Ag plus Zn to give Ag plus Zn2 plus. Okay, this is very simple. So what do we do here? The first thing we do is to bring them, split them into half cell, which is what? Ag plus to give us Ag, and Zn to give us Zn2 plus. If you look at it, this is plus 1 and this is 0. This one is 0 and this is plus 2. This is bigger than this by 1. So I will say Ag plus 1 electron to give us what? Ag. And for the fact that we added the electron on the left hand side, this equation is called what? This is what? Reduction reaction. All right, so look at this one. Zn to give us Zn2 plus what? 2 electron. Because we added the electron to the right hand side of this one, that one is what? A reduction reaction. And don't forget that the reactant of a reduction reaction is called what? Sorry, this is reduction, this is oxidation. Sorry, on the right hand side oxidation, on the left hand side reduction. And the reactant of reduction reaction is called reducing agent. Sorry, reduced species. Reduced species, you will start from species. Reduced species, as well as oxidizing agent. So the reactant of oxidation reaction is called oxidation or oxidized species, as well as reducing agent. Yes, oxidized species as well as reducing agent. So the next thing we do is to find their ratio. This is one electron is to 2 electrons. So we now cross multiply. 2 times this, you have what? 2 Ag plus what? 2 electron to give what? 2 Ag. All right, here 1 times everything is empty. Zn to give Zn2 plus what? 2 electron. So if we now combine it, this will now cancel out because they are not equal. So we combine it to have what? 2 Ag plus what? Zn to give us this side 2 Ag plus what? Zn2 plus. All right, so that is the balanced equation. Okay, so the next thing we talk about is balancing redox reaction when there is a presence of oxygen. Please, if there is the presence of oxygen, it is not the same thing with the one we did before. Okay, can I clean here? So write a subheading that said balancing redox reaction when there is a presence of oxygen. You can write it. All right, you now write, but when a species contain oxygen, all right, it is balanced in a different form. The first thing we do is to add water to the side with lesser oxygen. Add water to the side with lesser oxygen. So if I have this now, I'll have that this is NO3 minus to give us NO2 minus. Now, if you look at this, the number of oxygen here is 3. This is 3 oxygen. And number of oxygen is here is what? 2. This is 2 oxygen. So this is greater than this by 1. So we are adding only 1 molecule of oxygen. That is what we are adding. 1 molecule of oxygen. So this equation will become NO3 minus to give us what? NO2 minus plus what? Just 1 molecule of water. Not oxygen, sorry. Just 1 molecule of water. Because this one is lesser than this one by 1. Okay, so we're adding 1 molecule of water. Now, after adding 1 molecule of water, the next thing you do is what? To add hydrogen to the side without water. We add hydrogen ion, please. Hydrogen ion to the side without water. So I will have that what? This side does not have water. So I have NO3 minus plus, how many hydrogen do we have here? 2 hydrogen. So I will say 2 hydrogen plus. Remember that we are adding hydrogen ion, okay, to give us what? NO2 minus plus what? H2O. So if you now do this, the next thing to do is what? To now check the number of electron in the left hand side and in the right hand side. So here is what? Coefficient here 1. 1 times 1 is minus 1. 2 times this is what? Plus 2. Here 1 times minus 1 is minus 1. 0 times 0 is 0. So if you add these two, this side is giving me plus 1. If you add these two, this side is giving me minus 1. Okay, now this one is greater than this one by what? How do you get it? You can say this minus this. That is 1 minus then minus 1. You understand? The bigger one minus this. So 1 minus minus 1, which is what? 1 plus 1, which is what? 2. So this one is bigger than this one by 2 electrons. Okay, so I am going to add that 2 electron to the side that is bigger. Please, we are adding to the side that is bigger. You know that when we added water to the side with smaller oxygen. Okay, but in electron, we are adding to the side that is bigger because electron is a problem. So if you are bigger than me, I will give you more problems so that we will be equal. So that is why we are adding electron to the side that is bigger. So I will have that what? NO3 minus plus what? 2 hydrogen plus how many electron are we adding? 2, because this is bigger than this by 2. So I have what? 2 electron to give us what? NO2 minus plus what? Plus H2O. So this is a balanced redox reaction. So let us check if it is balanced. Remember, we said that it will be balanced in all aspects. Nitrogen is just 1 here. Nitrogen is just 1 here. Balanced. Oxygen is 3 here. Oxygen is 2 plus 1, 3. Hydrogen is 2 here. Hydrogen is 2. So all the atoms or all the elements are balanced. So now let's go to the charge. The charge here is 1 times this is minus 1. This time this will give you what? Minus 2. So minus 1 plus 2. Let's check the charge. The charge here is minus 1. This one is plus 2. Why this one is this time this will give you minus 2. So and the charge here is this time this is minus 1 and this one is 0. So let us check that. This and this is gone. So I'm left with minus 1 and this is still minus 1. So you see that the charges are equal. So it is a well balanced redox reaction. Okay, so let's solve another example. This is very, very simple. Let's solve another example. Another example said MnO4 minus to give us Mn2 plus. Okay, so you see that this one has what? Oxygen. So we are adding water to the side with what? With greater oxygen. And the number of oxygen is here is 4. And here does not have at all. So we are adding 4 molecule of what? Water. So I'm going to have MnO4 minus to give us what? Mn2 plus what? 4 molecule of water. Because this one is 4. So 4 molecule of water. Now the next thing we do is what? We add hydrogen to the side that does not have water. So but the total number of hydrogen here is what? 2 times this is 8. So we're adding 8 to this side. So I have MnO4 minus plus 8 hydrogen. But don't forget that the hydrogen you are adding is hydrogen ion, not hydrogen atom. Okay? To give you what? Mn2 plus what? 4H2O. And then you're almost done. So the last thing we do is to check the number of charges we have. 1 times this is minus 1. 8 times this is plus 8. Okay, 1 times this is plus 2. 4 times 0 is 0. So the both of them is giving me plus 7. The both of them is giving me plus 2. So let us subtract. This minus this is 5. So this one is greater than this one by 5 electrons. So we are adding that 5 electron to the side that is bigger. So I'll have what? MnO4 minus plus 8H plus what? 5 electron to give us what? Mn2 plus 4 water. You see? You are done. You can check if it is correct. Manganese is 1. Manganese is 1. Correct. Oxygen is 1. Sorry, oxygen is 4 and oxygen is 4. Correct. Hydrogen is 8. Hydrogen 4 times 2, 8. So the elements are equal. Now let's go to the charge. The charge here is 1 times this is minus 1. 8 times this is plus 8. This time this is minus 5. Now 1 times this is plus 2. 4 times 0 is 0. So we now see that this and this is minus 6. Minus this plus this will give you plus 2. Plus 2 plus 2. You see that it is a well balanced equation, right? It is a well balanced equation. All right, so let's move to the next one. The next one, they gave us ClO3 minus to give Cl minus. All right, the same method, it doesn't change. The first thing to do is to add water to the side that does not have oxygen, and this side oxygen here is 3, bigger than this, so I have what? ClO3 minus to give us what? Cl minus plus what? 3 molecule of water. Okay, then we now add hydrogen to the side that does not have water, but we have 2 times 3, 6, so we're adding 6 hydrogen ion, so ClO3 minus plus 6 hydrogen, but please don't forget that it must be hydrogen ion to give us what? Cl minus plus 3 H2O. Okay, so what do? The charges, 1 times this is minus 1, 6 times this is plus 6, 1 times this is minus 1, 3 times 0 is 0. So what do we have? The both of them is giving me plus 5. The both of them is giving me minus 1. So how do we check this minus this? So say 5 minus into minus 1, which is plus 6. So this is bigger than this by 6 electrons. So just add that 6 electron to this side. You are done. So my answer is ClO3 minus plus 6 hydrogen plus that 6 electron will now give us what? Cl minus plus 3 H2O. Very simple. Check if it is balanced. 1 chlorine, 1 chlorine, 3 oxygen, 3 oxygen, hydrogen 3 times 2, 6, 6 hydrogen. The elements are balanced. Let's check for the ion. The ion is what? 1 times this is minus 1, 6 times this is plus 6, and this time this is minus 6. This one is just minus 1, and this one is 0. 6 minus 6 is gone. I'm having that minus 1 is equal to minus 1. So this is a balanced redox reaction. Okay, very well balanced. So let's check for another example, and then the next example here said they gave us problem. They gave us Cr2, okay, O7 2 minus to give Cr3 plus. All right, the same method. The first thing to do is to add water to the side that does not have oxygen. This is 7 oxygen, so we're adding 7 molecule of water, because there is no oxygen here at all. So this is what? Cr2. But if there is oxygen here, we'll say the number of oxygen here minus the number of oxygen here. Remember, so this is 0. 7 minus 0 is 7. So we're adding 7 molecule of water. So O7 2 minus to give us what? Cr3 plus what? 7 molecule of water, 7 H2O. All right, so now we are not adding hydrogen ion to the side without water. So but 7 times this is 14, so we have Cr2O7 2 minus plus 14 hydrogen ion, okay, to give us Cr3 plus 7 H2O. Very, very simple. So the next thing we need to do is to check their charges. The charge here is 1 times this is minus 2, 14 times this plus 14. This one is what? Plus 3, and this one is 0. So this and this is giving me plus 12. Why this and this is giving me plus 3? So subtract 12 minus 3 will give you what? 10. So we're adding 10 electron here. So Cr2O7 2 minus plus 14 hydrogen plus what? 10 electron to give Cr3 plus what? 7H2O. Balanced. So what is now the problem? Let us check if it is even balanced. I have you see where there is a problem now. Okay. Is this correct? Sorry, this is not correct too, because if you look at this, you will see that that it is not balanced. So can we balance it? Let's see if after doing the first step is supposed to be to balance this first. That's the first step. But since I did not do that, so let us check if we can balance it from here. But if not, Can we balance it from there? Let me check the last answer. Okay, 6 electron. Okay, no. So sorry. Let me balance it first. Let me balance it first. That's the mistake I made. Okay. So the first thing to do is to balance it. CR is 2 here. Why CR is just 1 here? So what do? We balance it first by saying CR2 O2 minus 7 here to give 2CR3 plus. Okay. All right. So we can now start. So if we are starting now, what do? We add water to the side that does not have this. So we have the what? Cr2O7 2 minus to give 2Cr3 plus what? How many molecule of water? 7. So 7H2O. Okay, so that was the mistake we made in the first place. Without, I did not observe that here is 2, while here is 1. So it's supposed to be balanced first. So what do now? We cannot add hydrogen to the side without water. So we say Cr2O7 2 minus plus how many molecule of water? 14. So I'm adding 14. How many molecule of hydrogen is 14? So I'm adding 14 H plus to give us 2Cr3 plus 7 H2O. All right. So we can now check the ion. So this is a minus 2. This is a plus 14. And this one is 2 times this is 6 plus 6. And this is 0. So if you check the both of them, you have that this 2 is giving me plus 12, while this 2 is giving me plus 6. So this is bigger than this by 6. So we are not adding 6 here, then we are done. So Cr2O7 2 minus plus 14 H plus 6 electron to give us 2Cr3 plus what? 7 molecule of water. Then it is balanced. So let us check. Oh, always check, because if we did not check the other one, we would have assumed that it is correct. So let us check. Cr is 2. Cr is 2, correct. Oxygen is 7. Oxygen is 7, correct. Hydrogen is 14. Hydrogen is 14, correct. So let's go to the charges. This is minus 2 plus 14 and 6 will give you plus 6. So plus 6 and plus 6 is correct. So this is a balanced redox reaction. It's a well balanced redox reaction. So the next one is they said SO2 to give SO4 2 minus. Okay. So what do? We add water to the side with what? With smaller oxygen. So this is bigger than this by 2. So we're adding water, 2 molecule of water here. So I have SO2 plus what? 2 molecule of water. Okay, to give us what? SO4 2 minus. So what do we now do? So we're not adding hydrogen to the side without water. So we're adding 4 molecule of hydrogen. So I have SO2 plus what? 2H2O to give us SO4 2 minus plus 2 times 2, 4 hydrogen plus. Okay, so the next thing to do is to check the charge. The charge here is 0, and the charge here is 0. So the charge here is minus 2 and plus 4. All right, this time this is 4. So both of them will give you plus 2. So this is bigger than this by just 2, what? 2 electrons. So what do we have now? We now have that it is so this is SO2 plus 2H2O, sorry, to give SO4 2 minus plus 4 hydrogen plus what? 2 electron. So that is that. Very, very simple. So we move to the next one. I want to solve as many as I can so that you can understand it perfectly and then can solve by yourself. So the next one I have here said next one I have here said, okay, I've solved MNG this. Okay. Oh, oh, I even made mistake. This question said SO2. Sorry, SO2 plus plus MnO4 minus to give SO4 2 minus plus Mn2 plus. So this is the question. Oh, sorry. So we have to separate them into two half cell normally the way we do. So this one is that what SO2 is giving us SO4 2 minus, and MnO4 minus is giving us Mn2 plus. So let us now balance. Balancing this one, normally we are adding to this side like I did before. SO2 plus how many oxygen? This is bigger than this by 2. So I'm adding water, 2 molecule of water to give us what? SO4 2 minus. Since I've added 2 here, let me do it straight. 4 hydrogen plus. Okay? So now, if you now check that what they have here is 0 and what I have here is 4, that is minus 2 and plus 4, which will give you plus 2. So I'm adding an electron to the side that is bigger. So I have SO2 plus 2H2, okay, plus H2O, H2O, okay, H2O to give me SO4 2 minus plus what? 4H plus 2 electron. Okay, I added 2 electron because of you know the reason now. Because this is bigger than this by 2. So let's do the same thing here. I'm going to have here MnO4 minus, okay, to give us Mn2 plus. I left a space here for a reason, because I'm adding 4 water here. So 4 water, H2O. So which means I'm adding 8 hydrogen plus here, because 2 times 4 is 8. So let us check the charge. The charge here is minus 1, while the charge here is plus 8. The charge here is plus 2, while the charge here is 0. So this and this is giving me plus 7, while this and this is giving me plus 2. So this is bigger than this by 5. So I will say that what? MnO4 plus 8H plus what? 5 electron to give us Mn2 plus 4H2O. You see? So that is that. You will now see that we want the electron to cancel out. We want the electron to cancel out. So we now have that the ratio of the electrons we added is 5. This one is 5, and this one is 2. So we should cross multiply. If we cross multiply, we now have that what? 5 times this will give you what? 5SO2 plus 10 water to give this time this 5SO4 plus 4 times 5, 20H plus what? 10 electron. Okay, so then 2 times these people, 2MnO4 plus 2 times this 16H plus, okay, plus 10 electron, 10 electron to give 2Mn2 plus 8H2O. Okay, so this will now cancel this. So now bring reactant to reactant and then product to product. So I have what? 5SO2 plus 10H2O plus 2MnO4 plus 16H plus to give 5SO4 plus 20H plus, okay, plus 2Mn2 plus 8 molecule of water. Okay, so that is that for that. I think I've tried. So now let's talk Let's have some talk, then we end the class. I hope you have learned something. Okay, so the next thing we'll talk about, all right, notice that, notice that oxidizing agent as well as reduced species can be determined in a balanced redox reaction. Also, oxidized species as well as reducing agent um can equally be determined from a balanced equation. In fact, oxidation half cell reaction is a reaction in which its electron is on the left hand side. I said it before. Okay, then the reactant of oxidation half cell reaction is reducing agent as well as oxidized species. Right, now reduction half cell reaction, it is a reaction reduction half cell reaction is a reaction in which reduction takes place. That is, the electron of the reduction half cell is on the left hand side. I've said this thing before, okay, that if your electron is on the right hand side, it means it is what? Oxidation. If it's on the left hand side, it is reduction. So you can do this for me as your assignment. Plus S2O3 2 minus to give I minus plus S2O6 2 minus. Okay, you can balance that. So let's move. Test for oxidizing agent. Test for oxidizing agent. Number one, the following test is used to determine the presence of oxidizing agent. Number one, oxidizing agent changes the color of ion 2 from green to brown. All right, it changes the color of ion 2 from green to brown. Number two, oxidizing agent deposits yellow solid on reacting with aqueous solution of sulfide. The yellow solid deposited is sulfur. Test for reducing agent. Number one, reducing agent changes the color of acid solution of potassium tetraoxosulfate 6 or potassium tetraoxomanganese 6 or tetraoxomanganese 6 acid from purple to colorless. Number two, reducing agent changes the color of acidified solution of K2C2O2 from orange to green. You can go and study that. Now, in summary, summary. Number one, summary of definition of oxidation. The summary. Number one, oxidation means gain of oxygen. Number two, lose of oxygen. Number three, gain of non-metal. Number four, lose of non-metal. Number five, lose of electron. Number six, increase in oxidation number. Number seven, positive oxidation charge. All right, so these are the seventh summary to the definition of oxidation. Then for reduction, number one, loss of oxygen, gain of hydrogen, loss of non-metal, gain of metal, gain of electron, decrease in oxidation number, and negative oxidation charge. All right, oxidizing agent. Summary. Number one, donor of oxygen, because they donate oxygen. Acceptor of hydrogen, they accept hydrogen. Donor of non-metal and acceptor of metal. Acceptor of electron, okay. Oxidizing agent, you know that oxidizing agent is something as reduced species, so they accept electron. Acceptor of electron, okay, a substance whose oxidation number decreases from left to right. A substance which negative oxidation charge, okay, a substance with negative oxidation charge is called reducing agent. I know that reducing agent is same as what? Oxidized species. So now let's go to reducing agent. Reducing agent, reducing agents as well as oxidized species. The first one we did was oxidizing agent, which is reduced species. Sorry. So this one we are doing is now reducing agent, which is same as what? Oxidized species. Number one, oxidized species, number one said, is an acceptor of oxygen, donor of hydrogen, acceptor of non-metal and donor of metal, okay, donor of electron, a substance whose oxidation number increases from left to right, and a substance with positive oxidation charge. Please, please subscribe, like, comment, and share. We love you. God bless. Bye bye.